This is Randall Root, and in this video we are going to take a look at creating fact dimensions in SSAS. In the previous video we looked at creating a dates dimension. So we're going to go ahead and concentrate on a fact dimension. A fact dimension is a dimension that is created with all its columns being in the fact table. So for example, stores has 3 columns that are used for the dim stores dimension. But we could make a dimension on orders. It wouldn't be a very exciting dimension. It would just have a single column here, order number. We could actually at that point go through and create a separate table that would just have order number in it, but it would be just extra work and not provide a whole lot of extra benefit. So our choices are either to create a dimension just based off that one column in the fact table, or create a separate table which just has that single column. In those cases, most of the time, you just choose to create a dimension based off the fact table. It's easy to do. You right click and say create a new dimension. You advance the wizard just like we did in the previous videos. This time when you choose your table, you choose the fact table. Now, the way it works is if it's looking at a new dimension, it tries to find the key column, and it sees that there's a composite key across 4 columns. So it's asking the question, are these indeed the key columns of the dimension? And they are not. The key columns of the dimension is actually just the order number. It's the only one that's applicable to this dimension. Remember that the purpose of a dimension is to describe the sales quantity. So we have a given sales quantity like 15. With this particular dimension, we'll be able to figure out which order number that quantity of 15 was assigned to, along with which title, which store, and which date. So it is additional information about the measure that is, useful to know. And so that's why we're making a dimension of it. Because it doesn't actually have a name column, you can either leave it blank or set it explicitly to be the order number. I kind of prefer to use the explicit option. The wizard actually takes a look at the relationship lines drawn off of the table that is hosting the key column. So because it sees relationship lines here and here and here, it assumes that they may represent additional tables that host dimensional columns. In other words, it would create a snowflake design. Of course, it's not accurate. None of those have the columns that are going to be made up in this dimension, the orders dimension, and so we just uncheck those boxes. Same is true here. It thinks that maybe these other columns are associated with the current dimension we're working on, just like the other columns in the stores dimension would have been. But in this case, it's not correct. There's only one column that we're going to use for our current dimension, the orders dimension. If I want to, I can take out the space here in this user interface. I usually take out the space, so why not do it now? Then we need to give it a better name than fact sales, something that represents the fact that this is dimensional, like dim, and that represents order information, like order numbers, because really that's all that is in there. Since I'm using plural on the other dimension tables, I might as well use plural here too. And that's pretty much it. You have created a dimension at that point. Now, like I said, it's not a very exciting dimension, but we can process it and browse it and see what we have. problem with trying to film this in a small screen. Sorry, guys. So that you can watch it on like a cell phone is that you can't see all the buttons here. So I guess there's advantages and disadvantages. Anyway, I'm pressing the run button. Okay, so I have gone through and processed, and now I can go to the browser tab. May have to hit reconnect, but I can see the actual order numbers. Now, of course, a list of order numbers aren't very used without context. Aren't any use without context. So I'll need to go back to um, Server Explorer, Solution Explorer, and create a queue before this would be of any use to us. Since it's kind of hard to understand without that, let me do that now. Now I'll go through the cube wizard in just a bit, in a different video I should say. But right now I'm just going to go ahead and suggest which are my fact tables the wizard guesses correctly, and just accept all the defaults. Well, not quite. Let's see. It thinks that I'm missing, well, actually, it knows that I'm missing titles and authors, so it's going to go ahead and make them for me. I'll remove those in just a minute. But now I can go ahead and process the cube. Once again, you can't see it, but I'm hitting the run button at the bottom of the screen. Now when I go to the browser, I may have to hit reconnect, but I should be able to see the context of the order date dimension, or excuse me, orders number dimension. There we go. So a quantity of 15 was sold on this particular order number. Of course, adding additional attributes in here will help substantially. Next, I want to take a minute to show you how you could create a date dimension using a fact table. Currently, we already have a date dimension that has year, month, quarter, and the actual full date. It's been designed with a custom hierarchy and everything's set to go, so we really don't need to do this. But I want to show you that it's possible to go ahead and create um, a fact dimension using something like date. Not necessarily as a way of advocating this, just showing that it's possible. To give you some ideas of how you could use a fact dimension. So I'm looking at the fact table. I can see that the order date keys, they are completely artificial. They don't have any significance to the real world. But of course they do reference back to dim dates. And from there we can get, significant data, significant to the human that is, such as the date and the date name and so on. Well, we can actually accomplish this by using SQL code in a fact table. And the way you would do that is you'd go through and write some SQL code and test it, and then after you knew that it worked, you'd go through and create something like a data source view that had a fact table that you could utilize this and create a dimension off of it. So to give you an example of this, I've gone ahead and created a connection to the pubs database. And in the pubs database, I've created a data source view based on the original OLTP sales table. If I look in the data here, we can see we have order date, and it has the actual just the date time column. Now I want to use that to create a date dimension just to show it can be done. So I'll start by looking at the code in SQL Management Studio. And you can see here's the date. I'll isolate the date, and I'll go ahead and try a function like converting this date into something a little bit more useful. Um, Microsoft includes a convert function and a code, a format code. 112 is actually quite useful for making a date key. You can see that what it does, it puts in the year, the month, and the day. This is an integer value. It makes it really easy to create a key like that. Of course, there's other format codes such as 110, which puts it in the standard format that we use here in the United States of month, day, year. So I could perhaps use that first one, 112, for the key column and 110 for the name column. Now I might want to have other hierarchical ways of organizing the data, such as putting in months. So for example, I could go ahead and take that order date at the 112 format and take only the first 6 digits. So starting on the left, take 6 digits, and that would give me, of course, everything but the day. I could use that for a month key. For the name, I could extract the actual name and the year. Go ahead and like put a dash in there just to make it nice and nicely formatted. I I think this would represent our month data pretty well. For the year, there's not a whole lot to display here, but I could use something similar. Take the first four characters from the starting on the left-hand side from that key, and I'll use that as a key, and then the date name. Again, it's not very exciting, but now we've got the ability to get a order date key, a name column, month key, month column, or name column, and year key and name column. So if I combine them, I would basically have the makings of a pseudo dimension table, if you would. Um, that's not really a true term, but we now have data that can be used for dimensional analysis. Now the way you can use this is you can go through and take this code and create, like we're trying to create an order date key. I can go back to Visual Studio, I can right click on the sales table, and I could either replace it with a name query and completely replace it, or be a name calculation. If I make a name calculation, I just put in the column alias here at the top. I wouldn't put it down here, but I will go ahead and say, okay, this was order date key. Now I'm calling it order date key because instead of date key, because it only represents dates that are found in the orders table, and I want to be clear about that. You see, in the date dimension table, you have dates that are not necessarily found in the orders table as well, or sales table in this case, as well as ones that are in the table. It's all the dates in a given range. Whereas with a fact dimension, or order, a date-based fact dimension off the, in this case, the sales fact table, it would only give me the information or the data that was actually in the table, of course. Having a standalone dimension really is a better choice, but it's interesting that you can actually accomplish it by doing this in a pinch. And although I'm using the example of a date dimension, do be aware that it could be anything you could write SQL code for. Now, I would continue to do that for each and every column that I wanted to add to my table. Perhaps a simpler way of doing it would be just to include the other columns in my statement here. The other columns being we need store ID, order number, quantity, and title ID. I should clean these up, but I'm just going to keep this demo as simple as possible and just put in the raw data. Okay, we've got all our date ones, so now we need, let's put in title ID since title ID is dimensional. And I usually like to put all my measures kind of at the end, so I'll go ahead and put the only measure we have in this table of quantity at the end. Okay, let's see if I've got it working. Store ID, order number, title ID, order date key, name, month key, name, year key, name, and quantity. Like I said, these columns should be cleaned up and I should change the names and do all kinds of stuff, but we're not really here for that. Once I've got this code ready to go, I can then go ahead and use that and to replace the table with a name query. Or if I'd like, well, actually, to tell you the truth, I would normally just replace the name query, but I'll make a new name query so we can compare them side by side. Oops, got to paste the code at the bottom. I'll call it fact orders. I'll put a composite primary key on the 4-dimension columns. And now we have a table with name calculations added in. Let me see if I can add one more here. Let's see, how would we add the order name? Oops. Name calculation. Okay. Order date name. Excuse me. Get rid of here. Oh, now we got another one. Now let's look at how the data looks. I'll explore the data, and we'll see that we have the store ID, order number, order date, quantity, payment terms, and we have the order date key and order date name. So you can see that we've just added on these values. If I go and I look at the fact orders table that I just made, it's got the same values. Order date name, month key, date key, etc. In other words, going through and adding in named calculation columns is one option, and just replacing the table with a named query is another option. It's kind of up to you which one is best. In both cases, though, I can go through and create a dimension off it. I prefer doing the name query option, so I'll just go ahead and get rid of the sales table. Now I can go and create a new dimension, existing table. I do want to make sure I'm in the right data source view. You'll notice that dimensions cannot cross data source views, so and the only table in there is a fact orders table, so it is going to be a fact dimension. The key column is the order date, and the name column is date name, order date name. I want the month key and the year key, and I want to set them to date, calendar, date, date, calendar, month, and date calendar year. And I'll call it dem order dates. Again, I want to make sure that it's clear that it's only the dates in the orders table. So instead of just calling it dim dates, I want to make sure, that I give it something a little bit more descriptive. But after that, we can go through and do the standard setup that we did earlier, setting the name column. And the date one was already set. And also, I probably should change this a little bit, like say it's order date, no spaces, order month, no spaces, and order year, no spaces. And also build a hierarchy. And check the attribute relationships. Yeah, it didn't get it right. That's pretty typical. Month goes to year. There we go. And then I think I'll make them rigid. Doesn't really make much difference, especially on this size of database. You really won't see any processing performance, but I'm pretty sure that this is not going to change over time, so I'll go ahead and set that up. Okay, we should be able to process this, and we will see that that is indeed a legitimate date dimension, just not a complete one. So we have our years and we have our months. If some months are missing, it's because we didn't have any sales in those months. And order dates. Of course, the hierarchy. Now, I want to make it clear I'm not advocating that you should use a fact dimension for your dates instead of a full date table. For one thing, it's very helpful sometimes to find out what days you don't have sales on, and just other things that can be added to a date table, such as holidays and corporate events and things of that nature, sales events. It usually comes out to be a very good idea to create an actual separate date table. However, I think it's interesting to note that you can actually go through and create a complex fact dimension by using a combination of SQL code or just SQL expressions to modify your data source view in such a way that you can build a fact dimension off of it. Anyway, I think those are all the key points you need to know about creating fact dimensions. One other thing, remember that fact dimensions are also referred to as a degenerate dimension. It's the same thing. So if somebody says a degenerate dimension or a fact dimension, they're talking about the same thing. Degenerate dimension is the older name. I still use it myself, but I've been trying to force myself to use fact dimension because most people understand that one much better. Okay, hopefully you got something out of the video. Thank you for watching.